Have you ever looked at a really busy photo, maybe a crowd scene or just your chaotic family picture, and you can instantly find exactly what you're looking for, like the kid in the blue shirt hiding behind the sofa, or maybe something subtle, like that tiny scratch on the bike. For us, that just happens, right? Our brains are amazing at mixing what we see with what we know and figuring out context almost instantly. It feels effortless.
Yeah, absolutely effortless for us. But getting AI to that same level, to understand not just objects, but like the descriptions we use, the really nuanced language, that's been a huge hurdle for a long, long time in artificial intelligence.
And that's exactly what we're diving into today. We're looking at a really big step forward called Conversational Image Segmentation. It's a new capability powered by Google's Gemini 2.5.
That's right.
So our mission here is to take this pretty dense technical blog post from the Google developers blog and really unpack it for you. We want to turn the complex stuff into clear insights. So you walk away understanding not just what it is, but how AI is getting so much closer to actually, seeing and understanding images like we do, and what that really means for creators, for safety, even just for how we interact with tech day to day.
It's important to stress this isn't just a small tweak on what came before. It's more like a fundamental shift. How AI actually processes and interprets pictures. To really get how big a deal this is, we probably need to quickly look back at how AI vision evolved. From the very basic stuff up to this new conversational ability.
Okay, yeah, let's do that. That history really puts things in perspective, doesn't it? So what did it all start? Way back.
Way back, the very first goal was super simple. Just teaching a computer to say where something was in a picture. Think like the AI equivalent of a toddler pointing and just saying, car.
Right, just pointing it up.
Exactly. The AI would draw a simple rectangle around it. That's what we call a bounding box.
Okay.
You give it a picture, and it might spit out a box labeled car. It was a vital first step, basic recognition, but obviously very limited. It could say, there's a car, sort of here, but nothing about its exact shape or features or anything else, really. Very rough.
So like you said, just the location, basically, a very simple I Spy. But then things got better with segmentation models. How did they change the game?
Yeah, segmentation was a really big jump. Instead of just that rough box, these models could outline an object's exact shape, pixel by pixel.
Ah, okay. Much more precise.
Much more. Imagine tracing the car perfectly, every curve, every edge. Way richer information about its form. But, and this is a key but, even these models usually worked off predefined lists. They knew car, tree, person, because they'd been specifically trained on thousands of examples of cars, trees, and people. If you asked for something not on that list, say, a chihuahua wearing a tiny hat, it probably wouldn't know what to do unless chihuahua wearing a tiny hat was somehow in its training data, which is unlikely.
So it went from car somewhere here to here's the exact shape of the car. But only if it was a car the AI already knew about from its training list. It couldn't just figure out new things.
Exactly. That fixed vocabulary was the core limitation. I mean, think about it. How could you possibly pre-program every single object or description humans might come up with? It's infinite, right?
Is that right?
Yeah, impossible.
We describe things with so much flexibility. If you wanted an AI to find, say, a slightly dented blue thermos, you'd traditionally have to gather tons of pictures of dented blue thermoses, label them all, retrain the whole model.
Which sounds incredibly slow and expensive.
Totally impractical. It just doesn't scale. You hit this combinatorial explosion problem. The number of possible descriptions is just too vast.
And that leads us to the next big step then, the open vocabulary idea. How did that help break free from the fixed list?
Precisely. Open vocabulary models were a really significant shift. They allowed the AI to segment things using less common labels, things not necessarily on that fixed list it was trained on.
Okay.
The source gives examples like blue ski boot or xylophone. The model could understand blue ski boot even if it hadn't been explicitly trained on that specific combination before. It could combine its knowledge of blue and ski boot.
Ah, so it's not just about having a longer list, it's about understanding combinations and variations.
More flexible. Much more flexible. It started to handle the richness of language better. You weren't stuck asking, is there a dog? You could potentially ask, is there a fluffy white dog chasing a yellow ball?
Right.
It was still often matching pixels to nouns or simple descriptions, but the vocabulary it could handle was suddenly much, much wider, more versatile.
But even with that leap bounding boxes, then segmentation, then open vocabularies, we still weren't quite at that human level of understanding, were we?
No, not quite. There was still a gap.
And that's the challenge Gemini 2.5 is really tackling now with conversational image segmentation. This sounds like it goes way beyond just finding a blue ski boot.
It really does. It's about understanding truly complex, descriptive phrases, the kind of things you'd naturally ask another person.
Okay, so what does that mean in practice?
Well, it means moving beyond just, what is this object, to questions like, what's its relationship to other things, or what condition is it in? The source uses a great example to highlight this difference. Instead of just identifying a car, what if you want to identify the car that is farthest away?
Ah, okay. That requires way more than just recognizing car.
Exactly. It needs relational understanding farthest away. It needs spatial reasoning. It needs to interpret an abstract concept like farthest within that specific scene. That's the core of what Gemini 2.5 is doing differently. It's understanding the meaning behind the words in relation to the picture, not just matching labels.
So the AI isn't just labeling pixels anymore. It's genuinely comprehending the request, understanding how to find something based on a description. That feels like a really fundamental shift. How does Gemini actually do that? What makes this possible?
Well, the underlying intelligence is designed for this kind of flexibility. Google's developers have broken down the types of advanced questions Gemini 2.5 can handle into 5 key areas. And looking at these really shows you the depth of its new visual smarts.
5 categories. Okay, let's break them down. What's the first one?
The first category is object relationships. This is a big one. It means Gemini can identify things based on how they relate to other things in the picture, not just in isolation. It's about understanding the interactions, the context.
Okay, relationships. Give me an example. How does that work?
A classic one from the source is the person holding the umbrella.
Right. Easy for us.
Yeah. Trivial for us. But for an AI, it's complex. It's not just finding a person and finding an umbrella separately. It has to understand the action holding, the connection between them. That shows it gets the context, the interaction. Traditionally, you might need separate models, but understanding holding requires deeper comprehension.
That makes sense. A much richer understanding. And still within this object relationships category, there's also ordering, like finding the third book, not just a book.
Exactly. It can identify things based on their sequence or position. The example was the third book from the left. This shows real spatial reasoning. It can count, it understands ordinal positions first, second, third within the scene. It's not just seeing a flat image, it's interpreting the layout.
Okay, so spatial awareness too. And what about comparative attributes? That sounds even trickier, like it needs to make judgments.
It does. It's about comparing qualities. The source gives the example the most wilted flower in the bouquet. Right. It has to understand the attribute wiltedness, which isn't even binary thing, it's a scale, and compare that quality across all the flowers to find the one where it's most pronounced. That demands a really nuanced visual assessment, far beyond just simple recognition. Think about quality control, sorting things based on subtle differences.
Okay, so that's object relationships, interactions, order, comparisons, really powerful. What's the second big category of queries it can handle?
The second area is conditional logic. This means Gemini can filter what it sees based on complex conditions, even using not, setting specific criteria.
Conditional logic, like programming logic. If this, then that. Can you give an example, especially the not part? That sounds hard for AI.
Definitely. So you could ask for food that is vegetarian. That requires some world knowledge, right? Because vegetarian isn't always visually obvious. But even more powerful is handling negation, like the people who are not sitting. Negation is tricky because the AI needs to understand what isn't there or what isn't true, not just what is.
Right, identifying the absence of something.
Exactly. So it can find non-compliance or exceptions. Think about safety checks, workers not wearing safety vests, or inventory, items not in their designated area. It's super useful for filtering and auditing.
This seems incredibly useful for real-world checks and balances. Okay, category 3 sounds fascinating. Abstract concepts. How does an AI grasp something like damage?
This is where it gets really interesting and where Gemini's broad world knowledge comes into play. It can segment things that don't have a single fixed visual definition. Concepts like damage, as you said, or a mess, or even something like an opportunity in a business context may be represented visually in a chart.
How does it learn what a mess looks like? It could be anything.
Well, if we think about the bigger picture here, this is AI moving beyond just recognizing patterns into genuine interpretation, grasping the meaning of a scene. For damage, it learns to associate various visual cues, dents, cracks, scratches, discoloration, maybe even missing parts, with the abstract concept of being damaged. It's not looking for one specific damage object.
It pieces together the evidence.
Exactly. Same for a mess. It learns to recognize patterns of disorganization, clutter, things out of place, based on seeing countless examples in its training. It's inferring a state or a concept from the visual data, much like we do.
That's incredible. It's starting to sound like it's actually understanding the scene. Okay, moving on to category 4, this sounds very practical. In image text, it can read text inside the picture.
Precisely. This is a huge advantage. Gemini can use written text that's actually part of the image to help tell things apart, especially when they look visually similar.
Like boxes on a shelf.
Perfect example. If you have 10 identical boxes, but only one is labeled urgent, Gemini can read that label and segment just that specific box. This relies heavily on its built-in optical character recognition, or OCR. The source highlights this seamless fusion of vision and text understanding as a key strength. It's not just seeing shapes, it's reading the words, too.
That fusion seems really powerful. Traditionally, vision and OCR were kind of separate fields, weren't they?
Very much so. Bringing them together so tightly means the AI uses both visual and linguistic context. Think about product labels, street signs, serial numbers, warning messages. Text provides crucial information in the real world.
Yeah, absolutely essential for so many tasks. Okay, and the 5th and final category, this one sounds like it makes it usable everywhere.
Yes, the 5th category is multilingual labels. Gemini isn't limited to English. It can understand labels and queries in many different languages.
So I could ask in French or German?
Yep. You could ask for la voiture bleue or der rote Apfel, and it should understand and segment correctly. This makes it accessible globally, removing language as a barrier.
Okay, these 5 categories, relationships, conditions, abstract ideas, reading text, multiple languages, they cover a massive amount of ground. And here's where it gets really interesting. Thinking about how these aren't just cool tech demos, right? They're tools that unlock real-world applications. How do they actually change things?
Exactly. We've covered the how, the capabilities. Now let's talk about the so what. These aren't just theories. They're actively being used to transform industries and solve problems that used to be incredibly difficult or tedious.
So let's dive into those use cases. What's a prime example of where this makes a big difference?
One of the most immediate and visually impressive ones is unlocking creativity, specifically in interactive media editing, photo editing, video editing.
Yes. Anyone who's used Photoshop knows the pain of selecting tricky things.
Oh, absolutely. Trying to select just the shadow from a building, or wisps of hair against a busy background, or maybe a complex reflection. It often involves painstaking manual work, zooming way in, clicking pixel by pixel, refining edges.
It takes forever, and it's easy to mess up. It can really slow down the creative flow.
Exactly. It's a huge time sink for professionals, and frankly, a major barrier for anyone who isn't an expert but wants to do something more advanced than basic cropping. But now, with conversational image segmentation, the whole process changes. Designers can just tell the software what they want using natural language.
Instead of wrestling with the lasso tool or the magic wand.
Right. You could just say, select the shadow cast by the building, or select the reflection in the sunglasses, or select the logo on the t-shirt. The AI understands that description, using its grasp of relationships, lighting, maybe even text, and generates a precise selection mask, often instantly.
Wow. That sounds like it would save hours of tedious work.
It really does. It makes the editing process much more fluid and intuitive. It opens up sophisticated editing to people who don't have deep technical skills. It kind of democratizes it. And for the pros, it dramatically speeds things up, letting them focus on the creative side, the artistic choices, not the mechanics of selection. It's a massive boost for anyone creating visual content.
I can definitely see that. A huge time saver and creativity enabler. Okay, what's another area where this conversational vision is having a big impact?
A second really critical area is building a safer world through more intelligent safety and compliance monitoring. Think about places like factories, construction sites, warehouses. Safety isn't just about spotting objects. It's about situations and conditions. Are people wearing the right gear? Are walkways clear? Is machinery being used safely?
Right. It's not enough to detect person and hard hat. You need to know if the person is wearing the hard hat, or maybe, more importantly, if they're not wearing it when they should be.
Precisely. And identifying that non-compliance, especially with complex rules, has been very hard to automate reliably. With Gemini's conversational ability, a safety manager could use a prompt like, highlight any employees on the factory floor not wearing a hard hat and who are also operating heavy machinery.
Okay, that's a complex instruction, combining negation and an action.
Exactly. Gemini can understand that whole multi-part conditional query. It gets the not wearing part and the relationship to the machinery or location and the output. It's a precise mask, highlighting only those specific non-compliant situations or individuals.
So instead of someone having to constantly watch monitors or walk around checking.
It enables intelligent, automated monitoring. It
Yeah.
moves way beyond manual inspections, which are often spotty and error-prone, especially in busy environments. This can seriously enhance safety protocols, help enforce regulations, and ultimately prevent accidents. It's like having a tireless AI safety officer watching 24/7, a shift from reactive to proactive safety.
That has enormous potential for improving workplace safety. Okay, use case number 3, you mentioned abstract concepts like damage. How does that play out in the real world?
A really compelling application here is in the future of claims, particularly for nuanced insurance damage assessment. As we discussed, damage is abstract, right? It looks different depending on what's damaged and how. A dent is different from a crack, which is different from water staining or fire damage.
Yeah, and it can be really subjective. Plus, sometimes things look damaged, but they're just dirty or reflecting light weirdly.
Exactly. That subjectivity makes consistent assessment difficult for human adjusters and can lead to disputes or delays in claims. This is where Gemini's ability to understand abstract concepts, powered by its world knowledge, is a game changer. An adjuster could use a prompt like, segment the areas of roof damage consistent with hail, or highlight impact damage on the car's front bumper.
And the AI knows what hail damage typically looks like.
It leverages its training on vast amounts of data, including images labeled with specific types of damage. It learns to recognize the characteristic visual cues, the pattern of dents from hail, the specific look of water warping on drywall, the texture of scorch marks. Crucially, it also learns to distinguish actual damage from things that might look similar but aren't, like reflections, rust, shadows, or just dirt.
So it's not just pattern matching, it's using context and learned knowledge to make a judgment about the type and cause of the visual feature.
Precisely. The impact is potentially huge. More streamlined, standardized, and accurate assessments. Faster claims processing, reduced fraud, more efficiency for insurers. It brings consistency to a very subjective process.
Okay, these examples, creative editing, safety monitoring, damage assessment, they really show the practical power. It's not just clever tech, it's solving real problems.
Absolutely. They represent fundamental shifts in how these industries can use visual AI for tasks that really matter, moving beyond simple identification to intelligent interpretation.
So let's shift gears slightly. We see the amazing end results, but what about the people building these applications, the developers? How does this technology make their lives easier or open up new possibilities for them?
That's such a critical question because ultimately the impact depends on developers being able to actually use this technology effectively. And Gemini 2.5 seems designed with them very much in mind.
What's the #1 advantage for a developer using this conversational approach?
I'd say the biggest one is flexible language, moving beyond rigid, predefined classes. Remember how we talked about the old way? If you needed to segment something specific, like a Type 7 widget defect,
Yeah.
you probably had to train a custom model just for that.
Right. Lots of data collection, labeling, training, a major undertaking.
A massive undertaking, very resource intensive, especially for niche applications or small variations. It really limited what was practical to build. Gemini's natural language approach changes that completely. It gives developers incredible flexibility. They can build solutions for what's called the long tail of visual queries.
The long tail, what does that mean here?
It means all those highly specific, less common niche requests that wouldn't justify building a whole custom model. Things like segment the rip in the antique tapestry or identify the unripe berries on this specific type of plant. Developers can now address these super specific needs using natural language prompts without needing a dedicated model for every single one.
So it makes it feasible to build AI solutions for much more specialized tasks, industries that couldn't afford custom AI before.
Exactly. It opens up possibilities in specialized manufacturing, scientific research, bespoke retail, anywhere with unique visual requirements. The AI adapts to your specific need, described in language, rather than you being limited by the AI's pre-programmed list. It lowers the cost and speeds up development for these complex visual tasks dramatically.
That sounds like it really lowers the barrier for innovation in those areas. What else makes life easier for developers?
The second major benefit is a simplified developer experience, lowering the barrier to entry overall. Like we said, traditionally, developers needed deep ML expertise. They had to find or train models, figure out how to host them, manage the data pipelines, handle the compute infrastructure. It was a heavy lift.
Yeah, not something every developer or small team can just jump into.
Not at all. Gemini 2.5 aims to simplify that dramatically. Instead of juggling multiple specialized models and complex infrastructure, developers interact with a single, powerful API. They can apparently get started in minutes. The complexity of the underlying model is largely hidden behind that API call.
So it's more like using a powerful cloud service than building everything from scratch.
That's a great analogy. It makes sophisticated vision AI much more accessible. Smaller teams, individual developers, people who aren't deep learning specialists, they can now build intelligent vision features without needing that massive upfront investment in resources and expertise. They get to focus on the application itself, on solving the user's problem, rather than wrestling with the core AI tech.
It really sounds like they've democratized access to this cutting-edge capability, taking it out of the pure research lab and putting it into the hands of builders. That's exciting.
It really is. The goal seems to be fostering innovation by making it easier for more people to experiment and build useful things quickly.
So if a developer listening right now is thinking, okay, I'm sold, I want to try this, how do they actually get started? What are the practical first steps?
Google's made it pretty straightforward. There are a few ways in. For a quick visual exploration, there's an interactive spatial understanding demo right in Google AI Studio.
So you can play with it without writing code first.
Exactly. See what it can do, try out different prompts. It's a great way to get a feel for it. Then, if you want to dive into coding, maybe in Python, there's an interactive spatial understanding collab. That's basically a preset programming notebook that gets you up and running with actual code examples very quickly.
Okay, a sandbox and a ready-to-go coding environment. What about more detailed documentation or community support?
Yep. They have comprehensive developer guides for the Gemini API, including specific sections on image segmentation. And, really importantly, there's a developer forum. That's huge for connecting with other people using it, sharing ideas, asking questions, and getting help directly from the Gemini API team. Building that community is key.
Definitely. Learning from others and getting support makes a huge difference. Now, are there any specific tips or best practices mentioned in the source for developers who want the absolute best results from this segmentation feature?
Yes, they give some very practical advice. First, they recommend using the Gemini 2.5 Flash model specifically for this task. It's optimized for speed and efficiency.
Good to know. Use the Flash model. What else?
They also mentioned disabling something called the thinking set by setting a parameter called thinking budget to the 0.
Thinking budget. What does that do?
It's a bit technical, but the idea is to tell the AI to focus purely on generating the segmentation mask accurately and quickly, without spending extra computation time, thinking about broader interpretations, or generating extra text, which might be useful for other types of queries, but not needed for segmentation.
Okay, so basically, just give me the mask precisely. Don't overthink it for this specific job. Makes sense for efficiency. Anything else?
The last key recommendation is to stick close to the suggested prompt structure they provide, and always ask for the output in JSON format. JSON is a structured data format that's easy for applications to parse and use. They even give a sample prompt structure in the blog post, telling it exactly what keys to use for the bounding box, the mask itself, and the label.
That's super helpful, a clear template to follow, like a recipe for getting good results.
Exactly. Following these best practices should help developers get the most accurate and efficient results from the API. And looking at the bigger picture, Google's vision here seems clear. They believe that connecting language directly to vision at this pixel level is going to unlock a whole new wave of intelligent applications. It's not just about improving existing apps, but enabling entirely new kinds of interactions between humans and computers mediated by visual understanding.
Yeah, it really feels like we're moving towards computers that don't just process data we feed them, but can actually perceive and understand the world more like we do.
There's always more to learn, right? But this points towards a future where computers see and understand with a nuance that gets remarkably close to human cognition. Imagine AI assistants that can look around your room through your phone camera and answer detailed questions about what they see, not just recognizing objects, but understanding the scene.
Or smart home devices you could give complex visual instructions to. Find the remote control, it's probably somewhere on the messy coffee table.
Exactly. Or adjust the thermostat based on whether the cat is sleeping in the sunny spot again.
Huh, that would be useful.
Or think about creative tools. An artist describing a complex visual scene or modification, and the AI doesn't just generate an image, but provides segmented layers they can work with intuitively. It's moving towards AI as a true visual collaborator.
It really broadens the horizon for what's possible. So just to wrap up our deep dive today, we started with how easily we understand complex images and descriptions. Then we tracked AI's progress from basic bounding boxes to showing where things were.
To segmentation models outlining exact shapes but tied to fixed lists.
Then open vocabulary models breaking free from those lists.
And now, the big leap. Conversational image segmentation with Gemini 2.5. Understanding complex phrases, relationships, conditions, even abstract ideas like damage.
And reading text within images all across multiple languages.
Right, it's about comprehension, not just recognition.
And we saw how this isn't just tech for tech's sake. It's unlocking real value, making creative editing intuitive, boosting workplace safety through intelligent monitoring, and making processes like insurance assessment more accurate and efficient.
And crucially, making this power accessible to developers. Flexible language for niche problems, and a simplified API to lower the barrier for building these amazing vision applications.
So even though this sounds very technical, the impact will likely touch your life in many ways through better creative tools, safer environments, smoother processes. It's about technology starting to see and understand the world a bit more like we do. And here's a final thought to leave you with. If AI can now start to grasp abstract concepts like damage or a mess or even opportunity just by looking at pixels and using its world knowledge, what other, maybe even more subtle intangibles might it learn to perceive in the future?
That's a fascinating question.
Could AI learn to recognize something like potential in raw data or inefficiency in a workflow diagram, or maybe even collaboration in a team's interaction patterns visually? And how might that capability not only change AI, but maybe even help us see our own world with new eyes, with deeper insight? Something to think about.
This was the Gist Podcast. If you liked it, please leave a like and subscribe to this channel.